So in this second question, they've said that let vector A be equal to I cap plus 4j cap plus 2k cap. Vector B is equal to 3i cap minus 2j cap plus 7k cap. Vector C is equal to 2i cap minus j cap plus 4k cap. Find a vector D which is perpendicular to both A and B, and C dot D is equal to 15. This is the question. You must note it down. This is not ordinary product. This is dot product, also known as scalar product. Especially for the commerce students, don't call it into or multiplied by. Specific dot product should be mentioned or scalar product should be mentioned clearly. It is not ordinary product here. So here we go with the solution. Now you are being asked to find a vector D which is perpendicular to both A and B. When we talk about this portion of the question, you have to find a vector D. D is in the question. And what is special about D? It is perpendicular to both vectors A and B. In vectors, if we take cross product of two vectors, it always points in a direction which is perpendicular, you can say, to the plane containing both the vectors A and B. You are being asked to find a vector D which is perpendicular to both A and B. That means if we draw a rough diagram this way, if I take one of the vectors as A here, the other vector as B, this is a plane, it's a side view, and in this plane we have two vectors A and B. Now if I take cross product of these two vectors, it is going to point in this direction. This is the direction of vector A cross vector B. Now, cross product of two vectors always points in a direction which is perpendicular to the plane containing A and B. This should be remembered. This is very, very important concept. So you have to find a vector D which is perpendicular to both A and B. Now, perpendicular to both A and B means if we go for a vector like this is vector D. Now we can move this vector anywhere but parallel to itself. So this D is perpendicular to vector A because this vector D is perpendicular to the surface containing A and B. So if I shift this vector D anywhere in the surface, so it will be perpendicular to A, it will also be perpendicular to B. Now what we have obtained from here, once we have obtained A cross B, and we are they are demanding to find a vector D which is perpendicular to both A and B. If I go for A cross B, you will observe from the figure that vector D is coming out to be parallel to A cross B. Now if two vectors, they are parallel, then there exists a scalar or a constant lambda such that vector D, one of the vectors, can be written as constant times, this is ordinary product, and vector A cross B. If you have some confusion, you can write it this way only. It is lambda of A multiplied ki jagah yahan pe just need to write cross. This is ordinary multiplication. So what we can do, we can write this lambda as it is. When we have to perform cross product of two vectors, we have to make use of a determinant in which the first row elements, they are always I cap, j cap and k cap, essentially all the times. Then we pick the first vector A vector. Now from A vector, the scalar components are the numbers which are attached with I, j and k. With I, 1 is attached, so I'll prefer writing 1 here. With j, 4 is attached. With j, 4 is attached. With k, 2 is attached, so we write 1, 4 and 2. Likewise, For the vector b, we do the same practice. With I, what is attached? 3. With I, what is attached? 3 in the second vector. With j, what is attached? Minus of 2. With k, what is attached? 7. So we prefer writing it here. So we can perform the cross product by using a determinant. Let's open this determinant. We can write lambda here outside. This is ordinary bracket, and here we have ordinary product of lambda with the entire bracket. Lambda is a scalar. So I can write I cap here. Then I prefer writing minus of j cap here as per the sign scheme of expanding a determinant, and then plus of k cap with a bracket here. I have taken I minus j and k so that we don't have to think about positive or the negative sign. Just need to follow the grid of expansion of a third order determinant where we have positive, negative and positive along the first row. So I've written positive here, negative here, and this positive over here, right? This is a basic thing. Now with I must simply delete the row containing I and the column containing I, means this way. So I'll be left with 4, 2 minus 2 and 7. So product of these two elements, 7 4s are 28, and from there minus is in between, and minus 2 into 2, that makes it minus 4. So this makes it plus of 4. Be very, very careful that it's product of these two minus product of the other two. With j now, we delete the row and the column containing j this way. So I'll be left with 1, 2, 3 and 7. So it is 1 into 7, which is 7. From there I have to subtract the product of other two. 3 2s are 6. Likewise with k, I have to delete the row and the column containing k. So it is, these are the 4 elements left. So it is 1 into minus 2. I prefer writing minus 2 here. In between we have a negative sign, and 3 4s are 12. It is like this. So this comes out as lambda times 32 of I cap, and here we get minus of j cap and minus of 14 of k cap. Now if I expand it, what we get is 32 lambda I cap minus lambda j cap minus 14 lambda k cap. So we have obtained vector D, but it has an unknown lambda involved in it. So unless until we know the value of lambda, this answer is not going to be completed. So initially we have utilized this information that vector D is perpendicular to both A and B. This much we have utilized. What extra information is given? It is C dot D is equal to 15. We have written D but with unknown lambda involved in it, and C vector is also there. We haven't utilized C anywhere. So it is C dot D, which is equal to 15. Vector C dot vector D. Let us write vector C dot vector D. Vector C ki jagah will be writing 2I cap minus of j cap plus 4k cap. This is vector C, and vector D is what we have written over here. This is 32 lambda I cap minus lambda j cap minus 14 lambda k cap. This dot product is equal to 15, so I write 15 over here. No problem. Now when we perform dot product of two vectors, their respective components, that means components attached with I in both the places, will be multiplied together. Likewise, same is going to happen with the j components and the k components. So it is initially 2 multiplied by 32, that makes it, I'll prefer writing 2 and 32. Don't be in a hurry to solve, but do it correctly. So next is minus 1 attached with j, and with j we have minus of lambda. Product in between. This is ordinary product. This is also ordinary product because we are multiplying constants or scales. Likewise with k we have 4, and with k we have minus 14 lambda. Simply add them and equate it to 15. So let us simplify. This comes out as 64 plus of lambda minus 56 of lambda, and this is equal to 15. Let us simplify this. We get 64. We should write lambda as well. We have missed lambda, so 232 is 64, but of course lambda, this is 32 lambdas. We correct it here itself. So this is 64 lambda plus lambda, 65 lambda. 65 lambda minus 56 lambda. Okay? 15 minus 6 is 9 and 5 minus 5 is 0. So what we get here is 9 lambda, of course with a positive sign, you should remember, and this is equal to 15. So we simplify it further. Lambda is equal to 15 divided by 9. 3 5s are 15, 3 3s are 9. What we arrive at is lambda is equal to 5 by 3. Now you are being asked to find a vector D, where we wrote vector D, but what was missing? It was this lambda that was missing. So this lambda, which is 5 upon 3, must be utilized here, here and here to write our final answer. So we'll prefer writing the final answer as vector D is equal to 32 in product with ordinary product with 5 upon 3. This is with I cap minus lambda is 5 upon 3 of J cap minus 14 of 5 by 3 of K cap. Now let us simplify. That makes it 32 5s 160 divided by 3 of I cap minus 5 by 3 of J cap and minus of 14 5s is 70 upon 3 K cap. So this way our final answer is obtained. So very, very important concept we have learned here, we have to utilize it here, is that when we have to find a vector which is perpendicular to two given vectors, obviously the direction of that vector is going to be parallel to the cross product of those two vectors. Don't be in a confusion that D exactly is equal to A cross B. No, D will be parallel to A cross B. So that's why what we have written is vector D is equal to lambda, means unknown constant, times the cross product of two vectors A and B. This is also one of the most important sums from Cbse point of view. Over to the third question now.